Hi, in previous lecture I already discussed introduction to hashing, direct address table, hash table and chaining. So before starting this lecture, first go through previous lecture, then come to this lecture. Today I will discuss hash function. We have set of keys, we have hash table. For every key we'll find a hash value, we'll find a slot where we can insert that key in the hash table. So that hash value we find via hash function. We'll use hash function to find the hash value for every key. And for applying hash function, the key should be natural number. Even it is not natural number, you can convert it to natural number. In Corman book, there are two methods of finding hash value. First is division method. In the division method, for creating hash function, we map a key k into one of the m slot by taking the remainder of k divided by m. That is the hash function. So h of k equals to k mod m. K is the key, m is the table size and h of k is our hash value. So you can find the hash value by taking remainder of k division m. This is very popular method. We use division method for finding hash value. For example, suppose m equals to 12 means table size is 12 and key is 100, then h of k will be 4. 100 divide 12, remainder will be 4. 100 minus 96, it's 4. And when we are using division method, we should avoid some m value. So m should not be power of 2. If m equals to 2 power p, then h of k is just p, lower order bit of k. So you should avoid table size as power of 2. Next is multiplication method. It's a two-step method. First, we multiply the key k by a constant a. A should be range between 0 and 1 and extract the fractional part of ka. So that key will multiply with a and will extract the fractional part. Next, that will multiply with m. So then we multiply this value by m and take the floor of the result. So you can say h of k equals to m multiplication ka mod 1, its floor function. So ka mod 1 means fractional part of ka. In multiplication method, m can be power of 2 format. We can take m equals to 2 power p, p can be any integer. But in case of division method, it's better that m not equals to 2 power p. There are some other methods for finding hash value like folding, mid-square, truncation. In Corman book, just these two methods are given, and from these two methods, the division method is most popular. For collision resolution, we use two mechanisms. One is open hashing, another is closed hashing. Open hashing also called separate chaining. I already discussed chaining. Closed hashing called as open addressing. So next I will discuss closed hashing or open addressing. In open hashing or separate chaining, when collision occurred, we can use the chaining. We can add a linked list and we can store keys in the linked list. But in case of open addressing or closed chaining, we'll store everything inside the hash table. In open addressing, all elements occupy in the hash table itself. No extra space. That's why it also called as closed hashing. So each entry contains either the keys or nil. There is no chain concept. So no list or no elements are stored outside the hash table unlike chaining. In chaining, keys are stored outside the hash table in form of chaining or linked list. But in case of open addressing, all keys are stored inside the table. We use chaining rather than outside the table, we store inside the table. And here load factor never exceed 1. What is load factor? Load factor equals to n by m. N is the number of keys, m is the size of table. It cannot exceed 1. So maximum will be 1. Either it will hold one key or it will be empty. If empty, you can write nil. But in case of open hashing or separate chaining, it can exceed 1. It can be less than 1, it can be equals to 1, or it can be greater than 1. But in case of open addressing or closed chaining, it will be less than or equals to 1. Here we are not using the chaining, but we can use like chaining, means we could store the linked list for chaining inside the hash table. We can use the unused hash table slot. So advantage will be there will be no pointer. There are no pointer concept. In linked list there are pointer, we need to point. But here in case of open addressing there are no pointer. Everything will be inside the hash table. To perform the insertion using open addressing, we successfully examine, or it's called as probe, the hash table until we find a empty slot. Suppose we get a hash value that is already occupied, then we'll check the next free slot. Next free slot like this. So we'll continue this process until we find a free slot. So whenever we'll find a free slot, we can put the key there. So the probe sequence are h of k0, h of k1, like h of km minus 1. The algorithm for insert, hash insert tk, t is the table, k is the key. That key we want to insert in the hash table. I equals to 0, then repeat. J equals to h of ki. If t of j equals to nil, means that is free, then we can insert in that space. So t of j will be k and will return j. If it is not nil, then we'll increase the I value. So else I will be I plus 1 and it will continue until I equals to m. M is the table size. If we are not getting any free slot in whole table, then it's a overflow. So it will show error hash table overflow. It's all about insert. Next is searching. So this search can terminate unsuccessfully when it will find an empty slot or end of the table. It will terminate. Till that it will search. So this argument assumes that keys are not deleted from the hash table. Algorithm for searching, hash search tk, t is the table, k is the key that we are searching in the table, I equals to 0. Then repeat, j equals to h of ki. If t of j equals to k, means key present in t of j, then it will return j, else I will be I plus 1. Else we will search in next slot and that will continue till it's nil or end of the table. So until t of j equals to nil or I equals to m. In worst case, searching running time can be order of m. Suppose hash table size is 5, m equals to 5 and these are our key. 5 mod 5, remainder will be 0. So we'll insert 5 here. Next 10 mod 5, remainder will be 0. 0 slot is already occupied. So we'll insert in next free slot, that is 1. We'll insert 10 here. Then 15 mod 5, it's 0. So we'll insert 15 here. Then 20 mod 5, remainder is 0. 0 is occupied, 1 is occupied, 2 is occupied. We'll insert 20 here. Then 25 mod 5, it's 0. 0, 1, 2, 3 are already occupied. So we'll insert 25 here. Suppose we want to search 25. So 25 mod 5. 25 mod 5 will be 0. We'll search in 0 slot first. So t of 0 not equals to 25. Then I value will increase. Then we'll search in t of 1. It's not 25. Then t of 2. It's not 25. T of 3. It's not 25. T of 4. It's 25. Here hash table size is 5 and we are searching 5 times for 25. That's why running time is order of m. In worst case, we may search the whole table. In case of open addressing, deletion is difficult. We can solve this problem by marking deleted in place of nil. So whenever you are doing a deletion, just mark deleted, or you can use any symbol rather than nil. Nil means it's empty. But deleted means some key was there, now it's deleted. We'll use three commonly used techniques to compute the probe sequence required for open addressing. First is linear probing, then quadratic probing, then is double hashing. In linear probing, we use the hash function h of ki equals to h dash k plus I mod m. This h dash k is the first probe. So what will be our first hash value? That will be h dash k, and I can range from 0 till m minus 1, and our first probe is t of h dash k, and our next probe will be t of h dash k plus 1, and it will continue till table size, that is t of m minus 1. It's our last index. If table size is m, then last index is m minus 1. Linear probing is easy to implement, but it suffers from primary clustering, means lots of key can gather in same place. This primary clustering arises as probability for I slot will be I plus 1 divided m. Suppose this is a hash table and these are some slots, and now this is our I. So whatever key will enter, maximum probability that that key will come in this slot. So probability will be I plus 1 divide m. Suppose hash value are 0, 1, 2, 3 and I is 4. So any key whose hash value are 0, 1, 2 or 3, that will come in this place in 4 slot. So the probability is 4 plus 1 divide m. M is our table size. Long run of occupied slot tend to get longer and average search time increases. For any type of open addressing, worst case searching running time is order of m. Best and average is order of 1, but worst case is order of m. Let's see one example. This is a previous question. It was asked in ISRO 2016, question number 29. A hash function f defined as f of key mod 7 with linear probing while inserting the keys 37, 38, 72, 48, 98, 11, 56 into a table indexed from 0, in which location key 11 will be stored. Hash function is given. Here mod 7 means table size is 7. So first create the table. M equals to 7. So index will start from 0 till 6. 0 till m minus 1. First key is 37. 37 mod 7, it's 2. 37 minus 35, it's 2. So we'll insert 37 in slot 2. For key 37, hash value is 2, and that we found by this hash function. Next is 38. 38 mod 7, it's 3. We'll insert 38 in slot 3. Next key 72. 72 mod 7, it's 2. 2 slot is already filled. So as it already filled, now we'll do linear probing. Linear probing function is h of ki equals to h dash k plus I mod m. And what is h dash k? It's 2. Now 2 plus 1 mod m. 2 plus 1 mod 7. As slot 3 is already filled, so I'll check for next I. Now for I equals to 2. So 2 plus 2 mod 7 is 4. 4 slot is free. So can insert 72 in 4 slot. Next key is 48. 48 mod 7 is 6. 6 slot is free. So can insert 48 in 6th slot. Next is 98. 98 mod 7, it's 0. 0th one is free. So can insert 98 in 0th slot. Next is 11. 11 mod 7, it's 4. 4th one is already filled. So 4 plus I. First I will be 1, next 2, next 3 till m minus 1. So 4 plus 1 is 5. 5 mod 7, it's 5. We'll insert 11 in 5th slot. Next key is 56. 56 mod 7, it's 0. 0th slot is already filled. So we'll find 0 plus 1 mod 7. 0 plus 1 mod 7 is 1. So this first slot is empty. We can insert 56 in first slot. And in question it is asking in which location key 11 will be stored. Key 11 is stored in slot 5. So answer will be option C, 5. Suppose without creating you want to find the answer, then 11 mod 7. 11 mod 7 will be 4 and 4 is already an option. So you might think answer is 4. But when you are creating table, 4th slot is filled. That's why we are inserting 11 in 5th slot. Answer is 5. So you need to create the table for getting proper slot. In today's lecture, I discussed hash function and linear probing. In next lecture, I will discuss quadratic probing and double hashing. If today's lecture is helpful for you, please like, share and subscribe. Thank you.